Okay, lesson 4, dilating lines and angles. 4.1 is called angle articulation. Articulation, this word right here, is a noun. The verb is to articulate, and it's also an adjective. So you can be articulate, which typically means you're well-spoken, I guess. So essentially what we're doing is we're kind of articulating or speaking about angles. So here we go. Triangle A prime, B prime, C prime, right here, is a dilation of triangle ABC using center P and a scale factor of 2. Okay, so circle, star, underline, highlight. Really important. It's a good practice to get into. Circle, star, underline, highlight. All right, so we got triangle A prime, B prime, C prime, dilation of ABC, centers P, scale factors 2. So it dilated, so it's twice as big. So what do you think is true about the angles in ABC compared to the angles, the angles in A prime, B prime, C prime compared to the angles in ABC? All right, so what's true about the angles? It's an angle comparison. Compared. So we got to compare these angles. Now, what do I typically do in these scenarios? Well, I color in some angles. So we're talking about this one and this one. And again, I know it's moving kind of slow, but that's kind of how geometry is supposed to work. Go slow, don't rush. Sharpen these pencils. Okay. So, what do you think is true about the red angles, the orange ones, and the green? Well, it looks to me, this is just a what do you think question. But it looks to me it looks like angle C is congruent to angle C prime. It also looks like angle A is congruent to angle A prime. And it also looks like angle B is congruent to angle B prime. That's what it looks like to me. So it looks like, or I think, that's what you would say. Because they do look like they're the same shape. Now, use the tools available to figure out if what you thought was true. How could we do that? Well, easiest way on this is to use your patty paper. So I always like to use my patty paper conservatively so that we don't waste any. We got A, we got B, and C.
Good morning, Pumas. This is Mrs. Chahadia with your morning announcements, reminders, and phone trivia. Today, November 1st, is All Saints Day, and this month is also dedicated to honoring and recognizing the culture, traditions, and history of the indigenous people in North America. It is an opportunity to reflect upon the struggles that Native Americans have faced throughout history, as well as their contributions and resilience. From language preservation to cultural practices, there are many ways to learn more about and celebrate Indigenous cultures. Also, please take a moment to remember and honor lost loved ones on All Saints Day with special prayers, candles, and moments of reflection. Please feel free to bring a picture of a loved one to add to the altar in the atrium, and also dress up tomorrow for Day of the Dead. This week is Spirit Week. Today, Wednesday, we wear pink on Wednesdays. Thursday is Superhero versus Villains, and Friday is Pajama Day. Pumas, today you have blocks 2, 4, and 6 with only a 5-minute passing period. Please remember to get to your classes on time so that you can have a strong start to each of your classes. General announcements. Students, please be sure to check your emails daily for important reminders, assignments, and other opportunities. If you are playing a winter sport, your physical must be finished and turned in before November 2nd. See your coach or Ms. Franco in the main office for more information. Seniors, show up to drop-in hours during your free periods in the College Center. Get those applications in for CSUs and UCs as the deadline is November 30th. If you're interested in a career in the healthcare field, a Kaiser representative will be here tomorrow during tutorial for an info session. Please see Ms. Sanchez's email to sign up. LPS is hosting our first ever homecoming dance. HOCO will be on November 9th from 6 to 10 p.m. on campus. Tickets are $20 and non-LPS guests are allowed to attend but must have a permission slip signed by Principal Irving. Sales are happening all this week, so don't be left out. Boys and Girls Club tryouts will start tomorrow at MLK Park. Make sure that your physical is turned in. See your coaches for more information. Yearbook staff, please meet in the library during lunch. This meeting will determine who will be on the yearbook staff for the rest of the school year. Now for today's phone trivia. Please try to use your brain cells and not Google. Wait until I read the question to call extension 401 with your answer. The 6th caller will have a chance to win the Golden Puma for the day. Extension 401, 6th caller. What is the largest Native American tribe today?
No idea.
Mr. Gomez, congratulations. You have the correct answer. The Cherokee, Indians of Iroquoian lineage who constituted one of the largest political integrated tribes at the time of the European colonization of the Americas. Their name is derived from the Creek word meaning people of different speech. Congratulations to Mr. Gomez. Our Golden Puma is spending some quality time in some physical therapy. Congratulations. Let's have a great day on purpose.
Okay. So I like that line, have a great day on purpose. Why? It's up to you. Okay. So I just wrote the steps. Number 2, point B, center C, scale factor 1/3. Measure CB. 2.5 centimeters. Do your formula, which is here. So we're going to go CB times scale factor equals CB prime. C is the center, so it's not going to move. So CB is 2.5 times your scale factor 1/3 equals, show you how to do that, 2.5 times parentheses 1 divided by 3 equals 0.833. So this is CB prime is 0.833. There's 1 centimeter. There's half. In between is 0.75. It's like right there. B prime. Okay, we're done with 1 and we're done with 2. Number 3, dilate. So we're going to move point D using center C, scale factor of 3/2. So number 3. You end up going CD times 3/2. Remember, starting times scale factor equals CD prime. So how could you find CD? Well, just measure it. CD is 2.5. 2.5 times 3/2 equals CD prime. 2.5 times 3 divided by 2. Enter is 3. CD prime equals 3.75. There's 3. There's 3.5. There is D prime. Okay. dilate line CE using center C and scale factor of 2. Okay, so, C is on CE. So how do you dilate a line if the center is on the line? Okay, so C, you would just do the same thing. You would go CE times scale factor equals CE prime. CE is 5. Scale factor is 2. That equals CE prime. 5 times 2 is 10. That will equal CE prime. So I know that we dilate a point so that it's on the same line or ray. So line CE, you're gonna have E prime right here at the 10, because CE prime is 10 centimeters. So E prime is gonna be right here, but it's still gonna be the same exact line extending forever. So we did that. So what happens when the center of dilation is on a line and then you dilate the line? So if the center is on a line and you dilate the line, well, the dilated line is the exact same line, because a line, as you know, extends in both directions forever. So if the center is on a line and you dilate a line, it's the same line. We're going to talk about next when the center is off the line. That's when the center is on the line. Okay, I got one more plus the cool down, then we're done. Okay, proof in parallel. So, Jada dilated triangle A, B, C using center P and scale factor 2. That means that she did something like this. She measured P to C, doubled it, and then C prime ended up on the same line. She measured P to A and doubled it. So there's P to A, and then she doubled it. But remember, A prime is going to fall on the same line. And lastly, she measured P to B and then doubled it. And you'll find B prime ends up on the same line. Okay, so that was the directions. So Jada claims that all the segments in ABC, so the segments are A, B, B, C, and A, C. So she's saying that all the segments in ABC are parallel to the corresponding segments in A prime, B prime, C prime. So what she's essentially saying is that AB is parallel to A prime, B prime. So we got to write Jada's claim as a conjecture. So she's saying AB parallel to A prime, B prime. And it's a conjecture, which is an educated guess. She's also saying BC is parallel to B prime, C prime. So BC parallel to B prime, C prime. And then she's also saying that AC is parallel to A prime, C prime. So AC parallel to A prime, C prime. Prove your conjecture. This is a tricky proof. Okay. This is how you do it. You pick a point in between P and C that's on the line, and you name it E. So we're going to go up here. Call this one P. This point that I just chose, E, and C, and B. Now, if you dilate PC by a scale factor of 2, what's going to happen is C and E will stay on that line. So check this out. I know this is a little bit tricky, but you can draw like auxiliary lines in geometry, which is great. Helps you so much. Okay, so we are dilating by a scale factor of 2. E and C remain on that line. Look at this angle. Look at this angle. Dilated. We're proving that through our dilation is E prime. Sorry, excuse me. E prime's going to be like right here. My bad. This to this. But what you can see is that E and C fall on the same exact line. Now, this angle right here, which I'll color in red, is the same as this angle right here. I'll show you again. Why? Well, E and C stayed on the line. CB is dilated to a parallel line, so CB becomes C prime B prime. How can you prove that this is parallel to this? Well, because this one right here, this green line, serves as a transversal so PC prime is known as a transversal cutting across two lines, this line and this line, creating two congruent angles. The angles are in red here. So if you have a transversal across two lines and it creates two angles that are congruent, you can conclude that those two lines right here CB parallel to C prime B prime. And you do it by drawing a point E in between P and C. You end up dilating. E is going to end up like right here, somewhere around here. E prime, C prime, B prime will end up being parallel. Okay, I got 2 minutes to do the cool down, and then we'll be good. Okay, so here's the cool down. And we're done with lesson 3. Excuse me, lesson 4. Not lesson 4, lesson 4. Okay, so here is the image of triangle ABC. So here's ABC, and it's dilation using center D and scale factor 2. They're saying that DC is congruent to CB. So why is segment B prime, C prime on the same line, so B prime, C prime on the same line as its corresponding side, BC? The reason is because the center is also on the line. So, because the center, D, is on the line. Explain how you know that segment A prime, C prime is parallel to AC, its corresponding side. Well, dilations of line segments result in parallel line segments. So there's two options. D is either on the line, and then if you dilate the line, it's the same line, or D is not on the line, and in that case, that line gets dilated to a parallel line. What relationship does angle ACB have with A prime, C prime, B prime? Well, I'm coloring them both in red. So your answer to this is angle ACB is congruent to angle A prime, C prime, B prime. Because in dilations, the corresponding angles are congruent. All right, that question's on the quiz. Study the cooldowns, and you will do well on your quizzes.